Good afternoon. My name is Martin Zschoche, and I will be your science teacher for today. I'm going to start today by asking a question, which may seem to be obvious, but just thinking to yourself without saying it aloud, I'm going to show you an object in my hand, and I want you to think of what is this? What is this object that I have in my hand? Okay. Think to yourself, not out loud. All righty. Now let's have a guess. What's the guess? What do you think it is, Robert? Okay, that's an apple. Okay, and your notes, we're going to make a list of things, starting with apple. Okay, what else could this possibly be? More than just an apple. Susan? Okay, it's a piece of fruit, right? Yes, you can eat the piece of fruit, and the part that you eat is the pulp, right? Okay, Johnny, what else is it? It's got color. That's right. It's red and green. That's right. Very good. What else does it have here? Okay. Frank, what else? Yes, it's got a stem on it. And on the other side, it's got a little flower part. That's right. Okay. What else? What else can we say about this? Okay. You can use it to make apple pie. That's right. That's right. Or make an apple fritter. That's right. So what else could you use it for? Okay. So you can make apple juice. You can make apple sauce. Lots of different things, right? Okay. I'm going to share my screen with you. And the topic of today is the structure of the atom. The structure of the atom. Okay. So here's our agenda. So the essential question for today is what are the parts of an atom? What makes up an atom? And what makes atoms different from each other? And the main idea here is that the atom, as you may have heard, is the smallest part of an element. It's the smallest thing that we know of that still has all the properties of an element. It has protons, it has neutrons, and it has electrons. And the main difference between elements is that the number of protons they have in their nucleus. So I want to have you take a look at this next picture. On the left-hand side here, we're very familiar with the solar system. Um, and what makes up the solar system? We have our sun in the middle, and we have 8 planets that go around on the outside. That's very familiar to us. The other thing on the right-hand side may not be as familiar to you, but it's a stylized image of what an atom looks like. And let's look and see what the differences and what the similarities are between these two images. So let's take a moment. Frank, what do you think? What are you saying? Okay, so yes. So in the center of the solar system, you have one thing, one great big thing, right? And in the atom, you have at least two things. There's something blue and something red in there, okay? And what about the orbits? Yeah. Yes, Susie? Okay. So it looks like they both have orbits. They have things that are going around them. The solar system has great big planets, and the atom has these little black dots, which are electrons. Okay, great. Okay, let's take a look at a video that might help us to understand a little bit more about the structure of the atom.
Structure. We see it everywhere we look in the universe. from the elegant tendrils of spiral galaxies to the regular orbits of planets around a star like our own, to the DNA that carries the code of life. We see again and again that nature creates larger structures from collections of just a few smaller types of components, and this creates tremendous variation. Billions of stars are organized to make galaxies. Any number of planets and stars come together to form solar systems, and so on. If we continue to shrink our scale, we see that nature continues her trend of using modular constructs of just a few simpler structures to create a truly awesome and diverse universe. In this lecture, we're going to discuss one of the smallest systems that follows this tenet. Indeed, one of the smallest systems in all of creation, the atom. It's important to start our discussion by pointing something out. Atoms actually can be divided, but doing so causes something very special to happen that doesn't happen when we divide larger samples of elements. Take the example of a bar of gold. That bar of gold can be cut in half to make two smaller bars of gold. Those can be cut into smaller pieces as well, and they're still gold. And the process can continue, creating ever smaller and smaller samples of that element, gold. But if we could continue to do this perpetually, eventually we would arrive at a point where we have just one atom of gold left in our sample. So what now? Is that atom of gold truly indivisible? Actually, no. It can be divided, but in doing so, its identity changes. The two fractions created by splitting an atom of gold are no longer gold. They're something else. But this leads us to an interesting question. What are atoms themselves made of? If they can be split into other smaller atoms, then they must be made of even smaller pieces of matter than atoms themselves. And in fact, they are. Atoms are comprised of just three types of particles called subatomic particles. Positively charged protons, negatively charged electrons, and neutrons, which have no charge at all. Protons and neutrons are of nearly equal mass and reside in a dense nucleus at the center of the atom. But much smaller negatively charged electrons orbit that nucleus, balancing out the positive charge that's provided by the protons.
Okay, so let's see what we can learn from this video. Was the gold able to be divided? Well, yes, it was. And each smaller part of gold still looked like gold. It had the gold color. It was still a metal. It still had all the properties. But when they had got down to one atom of gold, could it still be divided? Well, yes, it could. But when you do that, it changes and is no longer gold. Let's go back and take a look at some of our vocabulary for today. So, Frank, would you read the first one? Yes, an atom is the basic unit of a chemical element. So we need to understand what a chemical element is. Okay, Susie, the next one, please. Okay. So the element cannot be broken down into something smaller without changing what the atom is, without changing its properties, right? And so what's in the center of the atom, we're going to call the nucleus. And so for your vocabulary words, nucleus is Nucleus. We see in this definition nuclei, which is the plural of nucleus. Okay. Robert, would you please read the next definition for us? Okay, a stable subatomic particle, so a particle that's smaller than the atom. It has a positive charge, which is similar to the electron. Okay, let's do the next one here. A subatomic particle about the same mass as the proton. So the neutron has the same mass but it doesn't have an electrical charge. Okay. And Henry, would you please read the last description there of the word electron? Once again, here a stable subatomic particle and it has a negative charge. Okay. So here's a chart which you may have seen before, you may not have, but this is called the periodic table of elements, and it lists all of the very unique elements of which everything that we know of is made of in the universe. In the upper left-hand corner, we have hydrogen, H, and it has a number 1 attached to it. That means it has 1 proton. And then if you go all the way down to the end of the gray boxes here, you have Oganasan, which is 118, and it has 118 protons in it. So it's a very unstable element. Some of these elements that you may be familiar with in everyday life here is aluminum, like the aluminum foil you have in the kitchen. You have oxygen here. We breathe oxygen. Here in the upper right-hand corner is helium. Helium we know from filling balloons, right? All righty, very good. So here's some of our reading. Atoms are made up of particles called protons, neutrons, and electrons, which are responsible for the mass and the charge of the atoms. So we have protons that have a positive charge, electrons have an electrical charge. And do you know of any other system that has a positive and a negative charge? Okay, so batteries do. That's right. Batteries have a positive side and a negative side. And then magnets, right? You have a magnet that has a positive north side and a negative south side. Okay, let's go down. Susan, would you please read this next line, this first bullet point, please? Okay, so the nucleus is one region, and the area around the nucleus is the second region where the electrons are. Okay, let's just keep going down. Protons and neutrons have about the same mass. Keep going. Alrighty, we have one negative charge, which is the electron, and a positive, which is the proton. And neutrons have no charge at all, exactly. Okay. Then, so the atom is the smallest unit of matter that retains all of its chemical properties. If you take the atom and split the atom, it no longer has that same chemical properties. And atoms can form molecules, which are larger groups of atoms, and those can be made of solids, gases, and liquids. Yeah, exactly right. Okay, let's go back to our agenda for the day. And I've already sent you your assignment. So we have 2 parts to the exit ticket. We have an independent practice. Please draw for me what you think of a simple atom that's showing 2 protons and 2 neutrons in its nucleus and 2 electrons going around the outside. So that may be in the form of this model on the right-hand side. That'll be fine. And then for your final exit, please answer this question. What makes an atom of one element different from that of another element? Okay, that's your exit ticket. And that's all we have for today. Thank you very much. Have a great day. See you.